Okay, so here is another example that we are looking to determine the slope of the tangent line for a square root function this time. All right, so at x equals 5, so the a value did not change. Okay, so what we have here is we are going to have to find the slope of the tangent line, or the IROC, as the limit of h approaches 0 of f at 5 plus h minus f at 5. Remember, I'm doing 5 because this is the a value. This is where the x is equal to. Okay, so this is my a value over h. So that's going to be the limit as h approaches 0 of the square root of 5 plus h minus 4, and then subtract the square root of 5 minus 4 all over h. So all what I've done so far is I replaced x with 5 plus h, and I replaced x with 5, right, for the second output. All right, we're going to simplify. So what I have here is I have the limit as h approaches 0 for the square root of 5 minus 4, so that's going to be h plus 1, minus the square root of 1, which is just 1, divided by h. Now, if I'm looking at this, what I see here is I see a square root in the numerator, and I can't simplify the numerator. I can't get rid of the h's. So what I'm going to do is I'm going to try and rationalize the numerator, so maybe I can get rid of the h, because basically what I need to do is I need to get rid of that h, because if I plug in 0, I'm going to get undefined. So to rationalize, I'm going to multiply by the conjugate. If you guys remember, that is the same function, but it will have a different sign in the middle. So in this case, I'm going to have to multiply by the square root of h plus 1 and then plus 1. So you guys remember that when I do that, I have difference of squares in the numerator, right? So remember the difference of squares. If you have a plus b times a minus b, then you're going to end up with a squared minus b squared. So the first term squared minus the second term squared. So in this case, the first term squared, so if I have the square root of h plus 1 and I square it, all what happened is that the square root and the square, they cancel each other, and I'll be left with h plus 1. And then minus the second term squared, so that is 1 squared, and that's going to be minus 1. Over, we're going to leave the denominator as is. We're not going to expand or anything like that. We're just going to leave it. And you want it in factored form because you want to eliminate the h. So look at this beauty here. So this and this cancel each other because plus 1 minus 1. Now what happened is the h and the h, they also cancel each other. So let me write that. So what you'll have the limit as h approaches 0 for h over h and the square root of h plus 1 minus 1, right? Or plus 1. So this h and this h cancel each other, and then you'll be left with 1 over that. Now, if I plug in 0, that's not going to affect me anymore, right? If I plug in 0, that's going to be the square root of 0 plus 1, which is going to be 1 over square root of 0 plus 1, that's square root of 1, which is 1, and then 1 plus 1 is 2. So that tells me that the slope of the tangent line is a half at x equals 1. At x equals 5. All right, so whenever you see square root in the numerator, for example, or denominator, then you want to try to rationalize. All right. Now, let's look at the next question. Now, this question is a little bit more asking you for more stuff, okay? So this one is asking you to determine the equation of the line, okay? So remember, it's the equation now. It's not only the slope, it's looking for the equation, okay? So it's looking for the equation of the line that is perpendicular to the tangent to y equals x to the power of 5 at x equals -2. This kind of brings us back to grade 10. Sorry, I don't know what's happening here. I changed something and okay, now it's good. So we're looking at the graph, which is x to the power of 5, okay? So I have a graph that looks like this, right? And I'm looking at -2, right? And this is my point here. This is my tangent line. But I'm looking at the equation of the line that's perpendicular to it, okay? So what I know is, I know that I can find the slope of the tangent line, but this is where you need to also think about the slope of the perpendicular line to that tangent line, okay? So if you guys recall, the slope of the perpendicular line is negative the reciprocal of the slope of the original line, okay? So let's step by step. Let's first find the slope of that tangent line, okay? Once I find the slope of that tangent line, then I'll worry about the perpendicular. So, I have y equals x to the power of 5, where x is equal to -2. So I'm looking at the slope of the tangent, or the IROC, where I have the limit as h approaches 0 for f at a plus h. So I have -2 plus h minus f at -2 all over h. All right, so let's find the f at -2. So I have the limit as h approaches 0. If I plug in -2 into my function, so my function is x to the power of 5. So I'm going to plug in -2 plus h to the power of 5 minus, and I have -2 to the power of 5 all over h. Now, we have not a problem per se, but we have something that is like -2 plus h to the power of 5. Now, if I'm going to sit down and actually do this and multiply, right, do this 5 times, right, that's going to take me a long time. I don't know if you guys recall the Pascal's triangle, because Pascal's triangle is what helps us kind of determine the coefficients of each of our term. Okay, so what Pascal's triangle is, and if you don't remember what it is, or if you have not seen it before, I would ask you to look it up. So Pascal's triangle is like this, where you have one on the top, and then basically that's for your first term, and then for your second, for n equals 0, for n equals 1, we have 1 and 1. For n equals 2, we have 1, 2, 1. So your outsides are always 1. In this case, this 2 here is the sum of these two. then we have for n equals 3, which is in this case the degree, right? You'll have 1, and then you add these two, that gives you 3. You add these two, that gives you 3, and then the last number is 1. Okay. For n equals 4, then you have again 1 on the outside. You add this, that gives you 4. Add these, that gives you 6, 4, 1. And then for n equals 5, we need to go all the way to n equals 5 because that's our degree. And that's going to be 1, 5, 10, 10, 5, 1. And these are the coefficient of my terms. I also look at, so the way it goes, if you have, let's say, a plus b cube, okay, the way it goes like this. So the coefficient of the first term is going to be 1, and it's going to be the first term cube, and the second term, it's going to be to the power of 0, which is just 1, so we don't have to write it. Then for the second term, in this case, your coefficient is 3, right? Your coefficient is going to be 3. And then the second term, that's going to have a squared, and then your b to the power of 1, which we just leave it as b. And then we have, again, in this case, your coefficient is 3 again, and then a, it's going to reduce by 1, so that's a to the power of 1, and then b is going to, the degree of b is going to increase by 1. And then for your last term, in this case, your coefficient is 1, so it's going to be plus 1, and then a to the power of 0, which is just 1. And we have b to the power of 3. So you see that the exponent of the first term decreases while the exponent of the second term increases. All right, so this is an example if I have a plus b cubed. Now what happens if I have a plus b to the power of 5? So I'm just going to move it a little bit because I need room. I know I like to write them all under each other, and they should be all under each other, but just I need the room here. So the coefficient of the first term is going to be 1. So that's going to be, I don't need to write it, right? And it's going to be negative 2 to the power of 5. All right, because my first term is negative 2. Then I have my second term, which is going to have a leading coefficient of 5, and then negative 2 to the power of 4, and then h just to the power of 1. Then I have the third term is going to have a coefficient of 10, and negative 2 to the power of 3, h to the power of 2. So you see how right now my exponent for the negative 2 is decreasing, the exponent of h is increasing. Then my next one is going to also be, I don't know why I put a negative, positive 10, and then negative 2 to the power of 2, h to the power of 3. Then the coefficient is 5, and then negative 2 to the power of 1, h to the power of 4. I'm just going to erase that for now. I can't erase it. And last, it's the last term, which is going to have a coefficient of 1, and that's going to be h to the power of 5. Okay. Okay. I'm just going to change this notation here for a second. Okay, I'm just gonna, so basically this is the expansion, but just because I didn't have too much room here. So this is basically the expansion of negative 2 plus h to the power of 5. This is expanding that. Okay, that's why I changed my notation, just because I don't have room. Now let's go back to the limit. So that's going to be the limit as h approaches 0 of, let's simplify it. Okay, so negative 2 to the power of 5, that is going to be negative 32. Negative 2 to the power of 4, that's going to be 16. And I have 16 times 5. And that's going to be 80h. Negative 2 to the power of 3, that is going to be 8. 8 times 10, that's going to be negative 8, sorry, times 10, that's negative 80h squared. And then what I have here is negative 2 to the power of 2, that's going to be 4, so that's going to be plus 40h cubed. Then for the next term, it's going to be negative 10h4 plus h to the power of 5. Now I don't want to forget that I need to include this in my limit, so that's going to be a minus and a negative, because negative 2 to the power of 5, that's negative 32. So that's going to give me positive 32. Okay, a negative and a negative gives me positive, all divided by h. And look at this. This and this, they cancel each other. And then you see that in every other term, I have h, right? So which means that I can factor out that h. And then you'll be left with 80 minus 80h plus 40h squared minus 10h cubed plus h to the power of 4, all divided by h. What happened here, the h and the h cancel, and then if I plug in h equals 0, then this is going to be 0, 0, 0, 0, and I'm going to end up with 80 as my as the slope of the tangent line at x equals negative 2. So this is slope of the tangent line at x equals negative 2. Okay, remember that we said that because we're looking for the equation of the perpendicular to the tangent, right? Which means I'm looking at a line that has a slope of negative reciprocal. Okay, so that means the slope of the perpendicular line is negative 1 over 80. So that's the negative reciprocal. Okay. All right. Now I determined the slope. Now I'm looking for the equation. So equation is for a line is y equals mx plus b. I already determined the m. I am looking to find my y-intercept. Now we know that this point passes through this, the x equals negative 2, and we determined that y will be 32, right? So let's write that down. So at x equals negative 2, f at negative 2 is negative 32. So the line passes through the point which is negative 2, negative 32, and I'm going to use that to find my y-intercept. Okay, so we know that the slope is negative 1 over 80 x plus b. We're going to use x and y, right? We're going to use these values to find b. So negative 32 equals to negative 1 over 80 times negative 2 plus b. The negative and negative cancel each other. The 2 and the 80, they simplify. So that's going to be 1 over 40 plus b. Okay. Now what I'm going to do is I'm going to bring the 1 over 40 to the other side. Find a common denominator. So that's 40. And that's going to be negative 1,280 minus 1 over 40. So b is negative 1,279 over 40, and that's a y-intercept. So the equation of the perpendicular line to that tangent is negative 1 over 80x minus 1,279 over 40.